The following particulars refer to a engine cylinder. Diameter of the cylinder equal to 400 mm. Steam pressure in cylinder is zero point 0.6 megapascal. Distance between the piston and crosshead is 1.25 meter. Find the diameter of the piston rod allowing a factor of safety of 4. Assume that the piston rod is firmly fixed to the piston and the crosshead. Take sigma C equal to 330 megapascal and A is equal to 1 by 7500. Use Rankine's method. Okay, this is the numerical. This is for 7 marks. So first, let us just try to understand this numerical. So this is of a IC engine or a steam engine piston. It's not an IC engine; it should be a steam engine. Because in case of IC engine, you don't have a piston rod; you have a connecting rod, right? So basically, what he has given in this is there is a cylinder like this. So cylinder is open on one side and a piston is attached to this or placed inside this cylinder. So there will be piston rings to this. Let us just put 3 rings. There is actually more than that, right? And there is something called as crosshead. So let me just show it like this. I'm just drawing the block diagrams. I'm not drawing the actual figure because that will take a lot of time, right? So there is a piston rod which is connecting the piston and the crosshead, right? So let me just name this is piston, this is cylinder, this is piston rod, and this is crosshead, right? And below this you will have the connecting rod and the crank, which is mounted on the crankshaft. So basically you have to design this piston rod, right? Now in the question he has given the diameter of the cylinder as 400 mm. So let us just move this down. Let me dimension this. This is 400, right? And the steam pressure is 0.6 megapascal. That is the pressure here P is equal to 0.6 MPa, right? So Yeah, steam pressure means it is a steam engine only. And the length of this piston rod is 1.25 meter, right? So let me just copy this. Okay, so this is the arrangement which is given in this numerical. Now we have to find load is not directly given. That is the only different thing in this. So we have to find the total load that is applied on the piston, right? So let us find this. Total load applied on piston. Now, how do you find the load? See, there is pressure here. Pressure is Newton per millimeter square. Pressure multiplied by this area of this piston or the cylinder will give me the load on the piston due to this steam pressure, right? So P P is equal to area of cylinder multiplied by steam pressure, right? Or P is equal to area of cylinder is pi by 4 d square. So pi d square by 4 into steam pressure is how much? 0.6. So I'll just call this as P here. So this is equal to, now let us put the values. Now what should I put the value of P? You have to put the value of D according to the value of P, or both should be consistent. So the pressure of steam is zero point 0.6 megapascal. 1 megapascal is 1 Newton per millimeter square. So if I put P in megapascal, I should put D also in millimeter, so that I will get the P, the load in Newton. So diameter is 400, pi into 400 square by 4 multiplied by 0.6. Let me calculate this. 400 square into pi into 0.6 by 4. So this is I'll just keep one decimal Newton. Right? You can just leave it like this, or if you want, you can make it into kilonewton. Not a problem. Right? Now, this is the actual load on the piston. You cannot change this load. Right? Now, I have to find the diameter. See, there are two types of numerical. One is the dimension of the rod or the column is given, and using that you have to find the load that it can take. The second type of numerical is the load is given, and using this load you have to calculate the uh, dimension of the column that is required. So this is all the second type of the numerical. Now he has given factor of safety of 4, right? So the Euler load, sorry, the Rankine load that is applied, or I'll just change this to W, or I'll call it as P dash. That is better. Just put a dash there. Right. Now the Rankine load that you are going to calculate, right, buckling load, should be the maximum load, right? The Rankine R is capital, load is thus P is equal to P dash into FOS, factor of safety, right? So this is equal to this much into 4. So this is your Rankine load P, right? Newton. Now for this load, I have to find the diameter. Now how to find the diameter? Rankine's equation is this: P is equal to PC by 1 plus A into LE by K square, right? So let me just take it here. We have Rankine's formula. P is equal to PC by 1 plus A into LE by K square. Right, now we have to find all the values. Now what is PC? PC is sigma C into cross sectional area. Now I do not have cross sectional area, so it will be in terms of cross sectional area. I'll just keep it as A there. 1 plus A value is given here already. LE by K. K is I by A, root of I by A. So everywhere you will have areas, or you can also use the other equation we used in the first numerical, right? This one. We can use this equation also. Now that is there also you will have everything in terms of area, right? So however you want, you can solve it. Now let us put the values in terms of A. We have crushing load PC is equal to sigma C, this is suffix, sigma C into what? Area. So area is pi by 4 B square, right? So this is equal to this into pi. I'll use a small d here because capital D we have used for cylinder. Pi d square by 4. Now d, you will get PC in terms of d square here. So this is equal to sigma c is how much? 330. So it is 330 into pi uh, into d square by 4. Let us just calculate the remaining part. 330 into pi by 4. So it is 259.18 d square, right? This is load. This I have put in megapascal or Newton per mm square. So this load will be in Newton because diameter is in mm. So this is in Newton, right? So this is PC. What else do we need? K. For calculating K, I need I. So moment of inertia of piston rod I. For a circular section, IXX, IYY both will be same. So you don't have to do any change there. So I is pi into d raised to 4 by 64. So this is equal to, I'll just copy this again. This will not change because I don't have the value of d, so I'll just keep it as it is. Pi d raised to 4 by 64. Radius of gyration uh, k is equal to root of I by 8, right? So this will give me k value. Now a is pi d square by 4. So this is equal to, let me just copy this, right? I is pi by 4 d square, so I'll just put that here. Sorry, pi d power 4 by 64, and a is pi by 4 d square. So I'll just copy this. Now pi gets cancelled, d square and d power 4. So 2 d's will go there. So it will be 4 by 64. How much is 4 by 64? 64 by 4 is 16 in the denominator. So this will be equal to root of, is a ratio. So this 4 will go to the numerator, 64 will come down. So 4 by 64 is, in the denominator I'll get 16, 1 by 16, right? Pi gets cancelled, and d power 4 by d square. So here I'll get d square, right? So d square by 16, 16 is 4 square. So this will be equal to d by 4, right? It's a square root, so radius of gyration is d by 4. What else is required? LE. What is LE? LE is the equivalent length. Now in the question, he says assume that the piston rod is firmly fixed to the piston and the crosshead. So both ends are fixed. When both ends are fixed, the LE equivalent length is L by 2. So since firmly fixed in piston and crosshead, LE is equal to L by 2, which is equal to 1.2 meters, right? It is 1.25, sorry, 1.25 by 2. How much is that? 0.625 meter or 625 mm, because everything is in millimeters, so I'll take this also in mm, right? So I got LE, I got K, A is there, PC is there. So I have all the values. Now I can put it in the Rankine's equation. So now P is equal to PC by 1 plus A into LE square by K. LE by K whole square, rather. Now PC is how much? 259.18 D square. So this is PC. P is also calculated, that is the Rankine load. So this is the Rankine load. A is how much? 1 by 7500. 1 by 7500 is A. LE is how much? 625. 625 by K is D by 4. So it will be D by 4 will go to the numerator as multiplication. So into 4 whole square. Right? So now let us just calculate this. This is equal. Now see here, this is divided by D square. Sorry, this is a addition, so we cannot do that. We have to solve it in the calculator only. Right? Just let's simplify a bit. Anything that can be done. Right? You have to cross multiply and do this, or directly you can do it in the calculator. So 301592.8 equal to 259.18 square divided by 1 plus 1 by 7500 into 625 into 4 divided by a square. Let me see if the calculator can solve this. If you are having a latest version, you can do this easily. Mine is a little old calculator. Still solving. Yeah, I got this. So or B is equal to 41.54 mm. What happened?
The 41.5.
Yeah, number of 41.54. Right? So this is the diameter of the piston rod required for this engine.